Hey, hi. Uh, in a video, I have explained in detail the introduction of relation, its mathematical representation, and also what is empty relation and all. In a video, I've already explained. So if you want, you can check that video. It comes on the top of the screen. Okay. Now, the continuation of that video, universal relation. Okay. First, mathematical representation I will show. R dash, I am taking R dash as universal relation, that is equal to A comma B colon modulus A minus B greater than or equal to 0. Okay. The given set is for empty relation also I have shown in that video. The set I have taken is 1 2 3 A is equal to 1 2 3 4. See, you take any numbers A and B from this set. For A, I will take, for example, 3. For B, I will take 4. So, A minus B means 3 minus 4. That is equal to 3 minus 4. We get minus 1 actually. Okay. Minus 1 will get, but they have used absolute value symbol. I mean, when you take this symbol, even if it is minus also, you will get plus 1. If it is plus 1, plus 1 only. If it is minus 1, plus 1 only. So when we use this symbol, modulus symbol, this even if it is minus also, we will get plus only. Like this, if you take any number, for example, for A and B, I will take 4, 4 only. For A also 4, B also 4, then I will get 0 according to the modulus I have taken. Right? So 4 minus 4 is 0. Modulus when you take, if it is minus, will get plus also. Plus only like this. Okay. See, if you continue taking any two pairs of numbers for A and B, and if we do A minus B, since we have used modulus symbol, if we get minus also, we get plus only. So whatever you get, the result will be either 0 or positive values. Positive values means what? Greater than 0. So either equal to 0 or greater than 0 we will get. So that's what they mentioned, equal greater than or equal to 0. Okay. So this condition is true, right? Because of this symbol, this whatever the condition they have given, this is true for the numbers if you take from this set. Okay. So for every number, for each and every element, if you take for A and B, this condition is satisfied. Okay. That is called universal. Universal, it means like all numbers will satisfy this condition. Okay. So universal relation, this is the meaning of this universal relation. So now we have to definition, we have to write mathematical definition. Whatever I have explained, same thing in systematic way we have to write the definition for this universal relation. So definition I am going to write a relation R. Okay. A relation R. Here we have taken R for empty relation, so that's why just to differentiate between that and this, I mean to show that is different, universal relation different, I mean empty relation is different, universal relation is different. I have just used R for empty relation, R dash for universal relation, but in general relation is represented by R only. Okay. A relation is R in set A, for this set A. Okay. Next is called universal relation. Is called universal relation if each element of A, if each element of A, I mean whatever the element you take, that's the meaning. If each element of A is related to every element of A, every element of A. Okay, so this is the definition. So each element of A is, I mean if you take any element of this set A, is related to every element of A. I mean, whatever, if you take 1, it is related to 2, it is related to 3, it is related to 4. Meaning, according to this condition, 1 minus, if you take 1 minus 2, this condition is satisfied. If you take 1 and 3, 1 minus 3, if you take this condition will be satisfied. If you take 1 and 4, 1 minus 4, that also will satisfy this condition. That is the meaning of this. Each element of A is related to every element of A. I mean, all numbers satisfies this condition. That is the meaning. So this is a definition. Okay. Now, how we represent, since all elements of this set are satisfying, this universal relation is represented by the mathematical relation like this. Mathematically, we represent universal relation are like this: A into A. That means set A. If take a element of set A is related to element of set A. I mean all elements of set A related to each and every element. Each number related to each other or each other. Like that, A into A we have taken. Now we have seen empty relation and this universal relation, right? So these two relations sometimes called trivial relations. Trivial relations. Okay. Empty relation and universal relation are both sometimes called as trivial relation. Next, now I will show one real life example for empty relation and another real life example for this universal relation I will show. First, real life examples. First, for empty relation. Okay. For example, set A we are considering all students of boys school. Okay, there is a school that is boys schools. I mean only boys, no girls. So in that school where the students are there, that set we are taking A. Okay. Next, using this, how can we represent empty relation? R is equal to A comma B colon. Colon is used for explanation. Here A B means any two students of this set A. A is one student, B is one student. That's the meaning. So how A is related to B? After colon we are writing A is sister of B. A is sister of B. Okay. See, this is example for empty relation. Why? Because see, this is boys schools, no girls are there. They are telling A is sister of B. Sister means what? Sister, she should be a girl, right? But this set is students of boys school. That means all are boys. When all are boys, sister is not possible because there are no girls in the school. So this is not possible. This relation is not applicable for this set A. That is empty. I mean, we cannot say there is a sister in this case. There is no sister at all. No sister means what? Null. I mean nothing. That means empty. There is nothing. So this is example for empty relation. So this second one. Next to universal relation. రేపు ఎగ్జాంపుల్లో సో r dash for this universal relation same set A we are taking. So how that relation is defining like this: A comma B. Okay, now what they are telling, difference between heights of A and B. Heights of A and B is less than 3 meters. Is less than 3 meters. So what's the meaning of this? See, AB, I mean, you take any two students from the set A. I mean, both are boys, right? This is boys school. Okay, first boy, second boy. Okay, heights. You take heights. See, usually, if for example I am an adult, right? My height will be maybe maximum 2 meters. More than that it is not possible. Okay, maximum 2 meter. This is a school. They're boys, I mean students. That means what? They are younger than me. I am only 2 meters. What will be the heights of this? Maximum what? 1 meter, 1.5. You, for example, you take 2 meter only. Okay, you take 2.5 only. Okay, usually that is not possible. If I say 2.5 meter height means very rare case, like out of 100 1 or 2 like this students will be there. Okay, for example, if I take 2 meter per student, per second I will take 1.5 meter. I mean per student height is 2 meters, second student height is 1.5 meter. So heights I have taken, heights of A and B I have taken. Next they are telling difference. Difference means you subtract. See, 2 minus 1.5. 2 minus 1.5, how much you get? 0.5 meter. Okay. Okay, I will take maximum height. For example, students of boys school, right? Maybe I think maximum 3 meter. Even that is also not possible. But I am just taking 3 meter example to make you understand. Okay, I am taking 3 meter only. Very highest number I am taking. I will take another 3. Okay, if you take 3 or 2.5 also. Okay, I will take maximum only 3 meter. If you take difference, 3 minus 3 is equal to 0 meter. Okay, if I take 3 minus 2.5, again it is 0.5 meter. See, so heights if you take and difference if you take, you can see 0.5 meter, 0 meter, 0.5 meter, right? So these are see that less than 3 meter, correct? The difference of heights is less than 3 meter, right? See, 0.5 is less than 3, 0 is less than 3, 0.5 is less than 3, right? That means what? This statement whatever is there, it is correct. I mean, if you take any students for A and B, if you take their heights and you take difference like this, the answer will be always less than 3 meter. So this is applicable for all the students of this set A, correct? All the students, all means universal, everybody, it applies to all. So this is the example for universal relation. This is real life example. I hope you understood. So anything if you want to see related to my teaching and this concept, please mention in the comment. And if you like this, please click on like and subscribe. Thank you.